Hello Math 8 scholars, this is Mrs. Carbajal here. Today we're going to be continuing our lesson on scatter plots and association. But notice how today I am using the math textbook for Math 8 and I'm going to be working in lesson 14.1, which is on page 435. For our lesson today, I'm actually going to skip on down to page 437 because we've already done explorations with this particular topic, okay? And I'm primarily going to be sticking to page 437. So just to kind of recap on what we talked about on Tuesday's lesson, we talked about something called association. And in algebra, you may refer to it as correlation. So remember, association describes how sets of data are related. We talked about there being three types. There's positive association, negative association, and no correlation or no association, okay? And again, we also refer to this as being bivariate or having some kind of relationship or no relationship between two data sets. So for instance, we might, later we're going to be talking about the price of an object as it relates to buyers. Over on the previous page, there is a discussion over here about intervals in minutes and duration in minutes. And we'll also see later a scatter plot having to do with reading level and height in inches. Okay, and so just remember that the data that show a positive or negative association and like basically along a line or a straight line roughly is called a linear association. So we're going to definitely come back to this next week. I was looking for a ruler, don't have one. If I were to try to make what's called a line of best fit, we see that more or less, if I dropped my pen or ruler down and try to connect as many points as possible, more or less, these points lie in a linear path, okay? Unlike the scatter plot that I uploaded, which had to do with our heights and our shoe size, that was a little bit on the non-linear side because the points were not bunched up nicely in what wanted to be a straight line. Okay, and again, on this particular example, this would be an example of a linear but negative association because again, it seems like those points are nice and tight around this line of best fit. And again, we have this no association, okay? So I want to just turn our attention here to this first example. It says Susan asked 20 people if they would buy a new product she developed at each of several prices. The scatter plot shows how many of the 20 said yes at a given price and describe the association between price and the number of buyers. So without even needing to look at the answer here, if we just take a look and examine the scatter plot, once again, we see that the input or the X variable has to do with price. And this price depends upon buyers. That kind of makes sense. So depends, our dependent variable would be the Y or buyers. And we're going to kind of go back to our three examples that we have here. Does this seem like it's a positive association? Does it seem like it has a negative association? Or does it seem like it's kind of everywhere and doesn't have an association? And according to this scatter plot, it does seem that this data lies in a negative association. Not only is it negative association, but they do not lie on a line. So the association is what we call nonlinear. Okay, so it kind of curves downward, so it's definitely negative. As price is increasing, the number of buyers seems to decrease. That makes sense. But it's not on a really nice tight line. I have some points that would be nice here, but we're missing out on all those points up there. So it's not quite as linear as we'd like it to be, okay? So the reflection question, what if? Based on the association shown in the scatter plot, what might happen if Susan increased the price to 14? So I can kind of make my own line of best fit here. And again, we'll do this with a ruler next week. If I see here that the price is over here at about 14, I'm willing to bet that she has very few or no buyers for this particular product. Okay, based on this graph, I think I can conclude that she's going to have no buyers. So if Susan increased the price to $14, she would, that should say have no buyers or few buyers, okay? Very few. So that's pretty much it. For the sake of this lesson, we're just gonna take a look at the graphs and see how we could classify the association. So in this your turn on number 6, we're gonna go ahead and take a look at the scatter plot that has to do with the reading level. So the input is reading level and the output is the height. So your job is to determine the association. So what kind of association does this graph have? Would you say it's positive, negative, or no association? And then give a possible reason for it. For instance, I could reason here and say, well, as a consumer, if the price increases on a product, less buyers are going to be more willing to purchase it. So what's the reason behind this particular association when dealing with reading levels and the height? Okay, that pretty much concludes our topic on scatter plots and association. What I'd like you to do is go ahead and take a moment to look at the guided practice problems on page 438. Everything I'm saying right now is repeated in the distant learning schedule in Google Classroom. I'd like you to go ahead and try problems 1, 2, and 3. You can skip number 4. And then go ahead and try the problems on the independent practice. Okay, so we're using this scatter plot to answer questions 5 through 8. Okay, but go ahead and answers 5, 6, 7, 8, 9. And what I'd like you to do is also answer problems 10 and 11. And I like these types of questions. It wants you to describe a set of real-world bivariate data that the given scatter plot could represent. Define the variable represented on each axis. So what I'd like to do is model an example of this. It's basically asking you to create your own story. So for instance, I think we saw this in one of the examples I gave you. Let's pretend like this was not labeled at all. So I'm trying to think of a real life situation in which it would have a negative association, or we could even do positive association. Okay, so let's see. How about as temperature? And temperature, again, it could be in Fahrenheit. As temperature in Fahrenheit increases, what can we say decreases? Well, there's a couple things. We could look at, see, as temperature increases, maybe, trying to turn my arm here sideways, maybe the sales of sweaters decreases. And I could put a money sign. Pardon my wrist, it's kind of hurting right now. So that's basically what it's asking you to do. So create your own story that has to do with this. And then when it's asking you to make your own story or make your own real world bivariate data, it's also asking you to define the variable represented on each axis. So what you're going to need to do after you label it, for instance, you can't take mine. I already used temperature and I used sweater sales. You're going to have to list the X variable. In my case was temperature. And then the Y variable in my situation was sales of sweaters. Okay, so give your own story to this graph and give your own story to this graph. And don't forget to state what the independent and dependent variables are. It would be helpful to label them. And then keep in mind, temperature and sales of sweater probably wouldn't be good for this graph because notice how it's going from the numbers 0 to 10. So please do keep in mind the numbers as well when doing these problems, okay? All right, as always, you guys, if you have any questions or concerns, you guys know when to Zoom. It would be wise to complete these, I think it ends up being 11 problems by Thursday, 3 p.m. But note that you are not going to be physically turning these into me, okay? This is all on the honor system. Okay, I hope you guys all have a good rest of your week. Take care.